Students, I am going to discuss about the number of stereoisomers in octahedral complexes. I have chosen an octahedral complex of this composition. M, this is the central metal atom, A2 ligand, B2 ligand, C2 ligand. If we take NH3 for A, Cl for B and pyridine for C, then its molecular formula becomes, say it is the cobalt, M is cobalt, it is now NaS3 twice, Cl twice and pyridine twice, plus 1. This is the complex of cobalt in which it carries the unit positive charge on the coordination sphere. We have taken two identical ligands for A, two identical ligands for B and two identical ligands for C. The resulting molecular formula for this complex of cobalt is like this. If you substitute metal by CO, then it becomes cobalt like this, again which changes to CO. It changes again into CO cobalt complex. This is CO and again it is CO. The study suggests that in such type of complexes we get the 5 geometrical isomers and 1 pair of optical isomers. The study suggests that in such type of complexes we get 5 geometrical isomers and a pair of optical isomers which we call together as enantiomer. So the total number of stereoisomers in this case is 6. Now I am going to draw the structure of these complexes. I have selected first time identical ligands in the cis position. This ammonia molecules are placed at the cis position. Similarly, chlorine is present in the cis position and pyridine also exists in cis position. So this is the cis isomer. This is the cis form. Cis form. Why cis form? Because both identical ligands are cis to each other. Both identical ligands are cis to each other. Ammonia cis, Cl cis, pyridine cis. So all the identical ligands are present at the cis position. So it is called cis form of the octahedral complexes. Now in this case what happens? Put all the identical or place all the identical ligands in trans position. So ammonia, it is in the trans position. Chlorine, it is in the trans position. It is pyridine, it is in the trans position. So the second form of octahedral complex is this. Number 2, this is the trans form. This is the trans form. Now see in this case what happens. Put two identical ligands at the trans position and rest on the cis position. So in the third form I have taken ammonia at the trans position and rest ligands are put at the cis position. So this is Cl and the pyridine and pyridine. तो you can say trans cis cis form है, trans with respect to ammonia and cis cis form with respect to ClCl and pyridine. So this is trans cis or cis. Now in this case, put chlorine at the trans position. Now ammonia at the cis position, pyridine at the cis position. In this case again, ClCl is at the trans position, so this isomer is trans cis. Trans position with respect to chlorine, but cis positions are due to ammonia and pyridine. Now in this case, put pyridine at the trans position and ClCl NH3 like that in the cis position. So this is trans with respect to pyridine, cis with respect to ClCl and ammonia. So these are the 5 structural representation for the octahedral complex belonging to this type. Now see the relations. All are the geometrical isomers. From 1 to 5, all are the geometrical isomers. From 1 to 5. 1 to 5 are the geometrical isomers. Because each one differ in geometry. Now see about the optical isomers. This cis form. Second point is structure first. Structure first is cis form. It has this symmetry. It has no any plane of symmetry. Hence, it is optically active. And when it is optically active, it would have certainly a non-superimposable mirror image. So the first form is the optically active form. It has no plane of symmetry, hence it is optically active. And when it is optically active, it is definitely has non-superimposable mirror image, or it has a pair of enantiomers. See in the rest of the structures, second, third, fourth and fifth, when you cut the this is the transform. Again this is the transform. This perfectly transform. Third is trans cis form. Fourth is trans cis form. Again this is trans cis form. So all these from 1 to 5 all are geometrical isomers, but one also shows the geometrical No, it also shows the optically activity because this form is dissymmetric. Dissymmetric. अगर आप इसको किसी, if you cut the in any plane, it has no plane of symmetry. But in this case, if you will cut this molecule in this direction, so along this and this, it has plane of symmetry. It has a plane of symmetry, so it is not optically active. Similarly, if you cut the in this plane, you will see the plane of symmetry. If you cut this in this plane, it has two equal halves. Similarly, if you cut through this plane, it has plane of symmetry. And likewise, it has plane of symmetry along this plane. So, all these have plane of symmetry except one. All these have plane of symmetry except one. This has plane of symmetry in this direction, like that. It has plane of symmetry. So, from 1 to 5, all structures are geometrical isomers, but form 1 is optically active because it has no any plane of symmetry. If you cut in any plane, it has no equal half. So, first form is geometrical as well as it is optical, as well as it is optically active or optical isomer. Now see the non-superimposable mirror image. It's a non-superimposable mirror image. You put the mirror here, mirror, and this is the structure. Like that, NS3 here, Cl, NS3, Cl, और यहाँ पर pyridine हूँ, this is pyridine. So this is non-superimposable mirror image. Non-superimposable mirror image. तो दिस फॉर्म इज ऑप्टिकली एक्टिव है और नॉन सुपरइम्पोजिबल मिरर इमेज है. इसका मतलब इट हैज गॉट है, इट इज एनंशियोमेरिक फॉर्म में है, इट मेक एन एनंशियोमर. तो टोटल number of stereoisomers will be total number of stereoisomers stereoisomers means optical plus geometrical. तो 5 फॉर्म होगा, geometrical and one pair enantiomer. A enantiomer, an enantiomer. An enantiomer total कितना हो जाएगा? How much total? It is 6. So 6. The number of stereoisomers in this example or in this octahedral complex is 6, out of which 5 are the geometrical isomers and 1 is enantiomer. So this is sufficient for this lecture. Thank you very much.